Hello, everyone. I am Hadi Amjad from National University of Sciences and Technology, and this work of ours was in collaboration with St. John's University and Merrimack College. In our work, we review different studies and researches that induce attention-based explainability mechanisms in the domain of healthcare where natural language processing techniques are employed. In this presentation, I will cover the general ideas that are included in our paper and our technique of the survey and our findings and observations in general. Deep learning approaches in general are black box, and explainability has become a growing concept to interpret the model's workings, figure out how they came to a certain decision, and the general transparency of the architecture as well. In the domain of healthcare, it becomes even more crucial to understand how a decision was made by an AI system because it directly impacts a human life. Clinical decision support systems rely on natural language processing techniques because textual data is concerned specifically in the case of electronic healthcare records. Explainable AI in general is a way to deduce the working of an architecture and understand how an architecture made decision based on the data it was given. It makes the AI system more trustable, more understandable, more comprehensible, and in general makes us treat AI systems better in our daily life and rely on them more. Explainable AI in healthcare is more crucial than generic fields because the loss here and a wrong decision here makes a lot damage than in any other field. Researchers try to improve the explainability and employ explainability in all of healthcare's different subdomains and tasks. In our work, we will be focusing on text data and CDSS systems. This diagram, in my opinion, explains attention mechanisms really well, and there are different types, which was taken from the paper I cited below. Attention in general for humans is a cognitive process that makes us focus on a subpart of a large array of data and information. That concept has been translated in deep learning as well, which we call attention mechanisms. The softness of attention is how the range of the attention and how much attention or focus we want to put on our data. Forms of input features tell us the type of data we would be inputting or the type of attention that may be employed on that data to figure out what its use or what its cost would be in decision-making process. Input representations help us understand the degree of attention we would be employing, and in output representations, we understand the mapping of the attention mechanisms on a certain type of data. In our work, we review all attention mechanisms employed on text data in the healthcare domain and where the attention mechanism has specifically been employed in the architecture for CDSS systems where text data is concerned and NLP techniques are used. Our methodology for this process was we searched PubMed and ScienceDirect directories with the keywords natural language processing, NLP, explainability, and clinical text. We kept the explainability portion generic, and we searched from durations of the year 2018 to 2022. And we found 26 papers in general that employed explainability in the architectures and were concerned with clinical text and NLP techniques in general. And from that work, we found that 60%, 16 papers in total, focused on attention-based mechanisms working directly with the architecture of their NLP techniques. We excluded the other 10 papers because their explainability was either self-explained by the researchers themselves, or it was descriptions from medical professionals and wasn't directly coming from the architecture themselves. Attention mechanisms healthcare NLP studies used 4 different kinds of models or deep learning techniques, which formed a base architecture, which later were incorporated with attention weights or mechanisms or other techniques. One of them were transformer-based architectures. The other was convolutional neural networks. Then we have gated residual networks and long short-term memory. And then at the end, we had some multi-model architectures as well. Transformer-based architectures are generally used very well with text data because of their sequence nature. They perform and give us benchmarks that are state-of-the-art. So it makes sense that they're being used a lot in CDSS systems for electronic health records. And attention mechanism used with them is generally local or self-attention. And the architectures, the work we reviewed, the architecture is mostly used for either ExelNet-based, BERT, or variations of BERT, and text CNN. The second was convolutional neural network. CNNs generally used for deep learning applications with text data. And when we use attention mechanism with them, they can tell us the most important information or the parts of data that impact a decision the most. Another way of using attention mechanisms was using attention weights in general, attention scores, and visualizing them to explain how what part of the text helped make the decision. And on the right side of the slide, you can see, or my right side, you can see the architecture and Camel. We used multi-channel concatenation and parallel pipelines for attention weights along with their data to put an enhanced attention mechanism on their architecture. Focusing on recurrent neural networks in general, LSTMs and GRUs are actually very commonly used for using attention mechanisms with them. And when we talk about text data, the case is no different. Generally, when we have a multi-model architectures, they can help us improve the input representations. In our case, we found a paper that used knowledge graphs, which can be considered inherently explainable, but that combined with the representation of text and going through attention mechanisms or multi-head attention helps us increase the explainability and the input representation and generally forms in the multi-model architecture category. In our findings, we found that attention mechanisms are more commonly used than other techniques as far as clinical text is concerned, and with the condition that the explainability is directly incorporated in the architecture and not post models are used or descriptions from medical professionals. The base architecture is most commonly used for text CNNs, BERT, and Camel, and their performance in general was greater than others because they have been benchmarked. Different attention mechanisms have been tested, and their input representation could either focus on tokens, self-defined tokens, words, labels, sentences, or layer-wise attentions. Evaluation of explainability component has been done in very few works. Some use Jaccard scores or local Lipschitz metric, or others use just visualization or heat maps, but there is no benchmark or no standard or no measurable criteria for the evaluation of explainability techniques, even for attention mechanisms, and that is something that we think future researchers can work on. In this table, you'll see different research works that we've cited in the paper and at the end of this presentation. Their models and the kind of data sets they use and the base architectures, and then the type of attention mechanism they use, and then their F1 scores macro. Hillard Clinical plus X used Mimic3 because a lot of these are electronic health record based, and they used ExelNet BERT, which would fall in the transformer based architecture category. And as I said, they used more label or self attention. Descriptive label attention network used Mimic3 as well, again with BERT and CNN, so it falls in both the categories, CNN and transformer based, and they use their own descriptions along with label attention. LATA is based with transformer based architecture, BERT and its variations. They use label wise attentions. MAGRN use GRUs with Chinese electronic healthcare records and use two kinds of attention. Again, we have JLAN, which use self-attention and label-wise attention, so two kinds of attentions. And Camel, which the diagram we already included in this presentation, had Mimic3 and Cody ESP, along with the base architecture of Camel and layer-wise attention. And then we have HLAN, which is being used in practical applications as well, as far as we know, that uses GRNs, which forms in the RNN categories, and they used two kinds of attention as well. Moving forward, we have Camel, which has become a base architecture for a lot of attention-based CNNs working in the electronic health records categories. Their base is CNNs. They used Mimic3 dataset, and they used only one attention mechanism, which was label-wise. Feng et al. Used BERT and text CNN, so it forms in the transformer-based architecture category. And then we have France ICD, which used a transformer-based architecture and used code-wise attention. Again, these are self-defined tokens. Then we have LAME, which used different kinds of data set, which are disease-specific, and they used BERT and used level-based architectures. And then we have the OSA and Mimic3 data sets with layer-wise attention. We have SWARM, which uses label-wise attention, and Camel, which was by Mullenbach, cited above. And then Gcoder is a multi-model architecture that uses both knowledge graphs and text representation, and they use layer-wise attention. As far as evaluation of the explanations are concerned, Xu et al. Used Lime and influential scores and used Jacquard similarity coefficients for their evaluation. LATA, which was transformer-based, used layer-wise attention, and again, he used Jacquard similarity coefficient. Hillad used label-wise attention, and they visualized their attention waste. So was the case was Zilag, and Feng et al. Used medical professionals combined with a novel approach for finding attention weights. So we did not exclude this from our work because they also use attention weights inherently in their architecture for explainability. 60% of NLP studies, according to our research from 2018 to 2022, use attention mechanisms. The most common of them base architectures used were Camel, which is itself is an attention mechanism-based CNN, text CNN, and BERT, which are transformer-based architectures. Difference in the studies relied on where in the architecture they used attention mechanisms, how many attention mechanisms they use, and what was their workflow in general. The basic pipeline for all the researchers that we have studied was they had dataset most commonly used Mimic3 or Code ESP, and then they used base architectures, which I talked about, Camel, text, CNN, or BERT, or any other variation, and then they had an attention mechanism used in that base architecture for explainability. The most important thing that is needed now in this research domain and for future work is a need for a standard evaluation criteria. So researchers can compare their evaluation of the explainability techniques they've used, and we can deduce what system or what architecture works better as far as attention based mechanisms are used or explainability used in AI models, specifically in healthcare. These are the references that we have included on our paper and our presentation as well. Thank you so much. For any questions, comments, or queries, which we widely welcome, please reach out to us, any of the 3 university colleges, and our emails are also included in our paper. Thank you.